Welcome. Today we are looking at thermal expansion. This is topic 8 in your SS1 physics series. This topic is common in objective questions in your examinations. Pay close attention. Let us begin. First, let me explain what thermal expansion is. Thermal expansion is the increase in size of a substance when its temperature increases. Most substances expand when heated. They contract when cooled. This happens because particles move more vigorously when heated. They take up more space. The particles vibrate more. They move further apart. This causes the substance to expand. Thermal expansion occurs in solids, liquids, and gases. However, the degree of expansion varies. Gases expand the most. Solids expand the least. Understanding thermal expansion is essential for many applications. It is essential for engineering and construction. It is essential for everyday life. Now let me explain why thermal expansion occurs. Thermal expansion occurs because of the behavior of particles. When a substance is heated, its particles gain kinetic energy. They move faster. They collide more often. They move further apart. This increases the volume of the substance. When a substance is cooled, its particles lose kinetic energy. They move slower. They move closer together. This decreases the volume of the substance. This is the basis of thermal expansion. Understanding why thermal expansion occurs is essential for understanding the phenomenon. Now let me explain the types of thermal expansion. There are 3 types of thermal expansion: linear expansion, area expansion, and volume expansion. Linear expansion is the increase in length of a substance. It occurs in one dimension. Area expansion is the increase in area of a substance. It occurs in 2 dimensions. Volume expansion is the increase in volume of a substance. It occurs in 3 dimensions. Each type is described by a different coefficient. The coefficient of linear expansion is alpha. The coefficient of area expansion is beta. The coefficient of volume expansion is gamma. These coefficients depend on the material. Understanding the types of thermal expansion is essential for solving problems. Now, let me explain linear expansion in detail. Linear expansion is the increase in length of a substance when its temperature increases. The formula for linear expansion is delta L equals alpha times L times delta T. Delta L is the change in length. Alpha is the coefficient of linear expansion. L is the original length. Delta T is the change in temperature. The coefficient of linear expansion depends on the material. Different materials have different coefficients. For example, aluminum has a higher coefficient than steel. This means aluminum expands more than steel for the same temperature change. Linear expansion is important in many applications. It is used in construction and manufacturing. Now let me explain area expansion in detail. Area expansion is the increase in area of a substance when its temperature increases. The formula for area expansion is delta A equals beta times A times delta T. Delta A is the change in area. Beta is the coefficient of area expansion. A is the original area. Delta T is the change in temperature. The coefficient of area expansion is approximately twice the coefficient of linear expansion. This is beta equals 2 alpha. Area expansion is important in many applications. It is used in construction and manufacturing. Now let me explain volume expansion in detail. Volume expansion is the increase in volume of a substance when its temperature increases. The formula for volume expansion is delta V equals gamma times V times delta T. Delta V is the change in volume. Gamma is the coefficient of volume expansion. V is the original volume. Delta T is the change in temperature. The coefficient of volume expansion is approximately 3 times the coefficient of linear expansion. This is gamma equals 3 alpha. Volume expansion is important in many applications. It is used in construction and manufacturing. Now let me explain thermal expansion in solids. Solids expand when heated. They expand in all directions. The expansion depends on the material. Different materials have different coefficients of expansion. Metals generally have higher coefficients than nonmetals. This means metals expand more than nonmetals for the same temperature change. Thermal expansion in solids is important in many applications. It is used in construction, manufacturing, and engineering. Expansion joints are used in bridges to allow for expansion. Gaps are left between railway tracks to allow for expansion. Pipes have expansion loops to allow for expansion. Understanding thermal expansion in solids is essential. Now let me explain thermal expansion in liquids. Liquids also expand when heated. Liquids expand more than solids. The expansion depends on the liquid. Different liquids have different coefficients of expansion. Water is unusual. It has anomalous expansion. Water expands when cooled below 4 degrees Celsius. This is called the anomalous expansion of water. This property is important for aquatic life. It allows ice to float on water. If water did not have anomalous expansion, lakes would freeze from the bottom up. This would kill aquatic life. Understanding thermal expansion in liquids is important in many applications. It is used in thermometers and engines. Now let me explain thermal expansion in gases. Gases expand significantly when heated. Gases have the highest coefficient of expansion. The expansion of gases is described by the gas laws. Charles's law states that the volume of a gas is directly proportional to its temperature at constant pressure. The volume increases as temperature increases. The volume decreases as temperature decreases. The formula for Charles's law is V1 over T1 equals V2 over T2. V1 is the initial volume. T1 is the initial temperature. V2 is the final volume. T2 is the final temperature. The temperature must be in Kelvin. Understanding the expansion of gases is essential for understanding thermodynamics. It is used in engines and refrigeration. Now, let me explain the anomalous expansion of water. The anomalous expansion of water is a unique property. Water expands when cooled below 4 degrees Celsius. Most substances contract when cooled. Water contracts when cooled from higher temperatures to 4 degrees Celsius. Below 4 degrees Celsius, water expands. This means water has its maximum density at 4 degrees Celsius. This property is important for aquatic life. When water cools in winter, the colder water rises to the top. It freezes. Ice floats on the surface. This insulates the water below. Aquatic life can survive in the water below. Understanding the anomalous expansion of water is essential for understanding aquatic ecosystems. Now let me explain the applications of thermal expansion. Thermal expansion has many applications. It is used in thermometers. Thermometers use the expansion of liquids to measure temperature. The liquid in a thermometer expands when heated. It rises up the tube. The temperature is read from the scale. It is used in thermostats. Thermostats use the expansion of metals to control temperature. A bimetallic strip is used. Two metals with different coefficients of expansion are joined. When heated, the strip bends. This opens or closes a switch. It is used in bridges. Expansion joints allow bridges to expand and contract. They prevent damage from thermal expansion. It is used in railway tracks. Gaps are left between rails to allow for expansion. This prevents buckling. It is used in pipes. Pipes have expansion loops to allow for expansion. This prevents bursting. It is used in engines. Engines use thermal expansion to do work. Understanding the applications of thermal expansion is essential. Now let me explain the importance of thermal expansion. Thermal expansion is important for several reasons. First, it affects the design of structures. Engineers must account for thermal expansion. Second, it affects the accuracy of measurements. Measurements must be corrected for temperature. Third, it affects the performance of machines. Machines must be designed to accommodate thermal expansion. Fourth, it affects natural phenomena. Thermal expansion is responsible for many natural phenomena. Examples include sea level rise and weather patterns. Fifth, it affects everyday life. Thermal expansion affects cooking, heating, and cooling. Understanding thermal expansion is essential for many fields. Now let me give you sample exam questions. Define thermal expansion. Thermal expansion is the increase in size of a substance when its temperature increases. State the formula for linear expansion. Delta L equals alpha times L times delta T. State the formula for area expansion. Delta A equals beta times A times delta T. State the formula for volume expansion. Delta V equals gamma times V times delta T. Explain the anomalous expansion of water. Water expands when cooled below 4 degrees Celsius. Explain the applications of thermal expansion. Thermometers, thermostats, bridges, railway tracks, and pipes. Let me summarize. Thermal expansion is the increase in size of a substance when its temperature increases. There are 3 types: linear expansion, area expansion, and volume expansion. The coefficients of expansion depend on the material. Gases expand the most. Solids expand the least. Water has anomalous expansion. Thermal expansion has many applications: thermometers, thermostats, bridges, railway tracks, and pipes. Understanding thermal expansion is essential for physics and engineering. Practice these concepts. When you have them down, move to topic 9.